An elasticity or no?
Ready?
Set.
That would have a greater momentum than compared to my momentum.
No, just kidding.
Okay, cool.
Oh, okay.
Okay,
Are
so,
you ready?
alright, so what I want you to do, sir. Alright, definitely. Okay, so let's try it the other way around. Oh, that was... Okay.
It feels when you go faster. I don't know. Never mind.
It's a function of mass and velocity. Yeah, that's
Yeah,
change of
yeah,
velocity.
exactly.
Mass and change of velocity. Yeah.
So instead of just talking about it, let's see it. So,
Exciting! So, and we're also going to talk about a lot of optical illusions today, or a certain type of optical illusion, where we're going to create an image of an object, and it's going to look different than the object actually does on it, that sends a signal to your brain, and then your brain processes the information to say, there's a light bulb here. What's assumed in all of this is that your brain assumes that the light coming to it always travels in straight lines. If you are looking in a mirror to look at this light bulb, light comes from the light bulb, hits the mirror, reflects back to your eye, and where does your eye think, or where does your brain think that the light actually, and look at it as I'm filling it up with water, you can notice this effect that Damolo is talking about.
Oh, yeah.
That it actually looks like it's physically cut in half and like moved.
It looks larger, too.
And it looks larger, and that's also an effect having to do with refraction, but it's harder to explain, so I'm not going to explain it, all right? The light's actually coming from there, but when it leaves the water and enters the air, it changes directions. So our brain thinks the light came from over here. You just want to be able to barely see the edge of the penny. And this penny is glued to the bottom of the cup, so it's not going to move. It's not going anywhere. And I am going to make the penny reappear. All right, everyone got it? Don't move once you've got it.
Okay.
Just barely see it. Oh, snap is right. Okay, why? Why do we see it now? What happened? Because of refraction. It is an example of an optical illusion, and it has to do with refraction. You can tie it all up.
The light is bending over the edge of the cup.
Actual penny, the same angle we saw it before, we're seeing light that was going up and then bending away from the vertical towards us. So that's how we can see it disappear, just by pouring in some very magical liquid. But to prove to you that it's not just any liquid, I'm going to show you that this one, when I pour water in it and cover it in water, you can still see it, right?
Yeah.
Like it's still there. It's kind of like harder to see, and if you bend down and look, it looks a lot bigger. But you can definitely tell that it's there, right? And keep your eyes on it, because in a second, it's not going to be there anymore.
Whoa. It's still there. Just saying.
Oh, yeah, I
can
saw
see
Yeah,
it.
you can see the dot, right?
And I still see the
You
top.
feel the edges, you can almost see
Yeah,
it.
the edges.
What
You
is
guys
that,
have really good
detergent?
eyes.
You can see like the
Is that
outline.
It's
of it.
actually vegetable.
please make sure that you will look to, let me see, like this, okay? Make sure that you look there, but also you will look kind of to the side to see the colors, right? Okay? So, which one is stronger? The green. The green.
Oh,
Now,
you guys can guide each other.
you see,
know how to go further in that, but you're on the right track.
and now show us with the green, please. And we will overlap. What's your name?
Marilyn.
Marilyn, yeah. Okay, Marilyn, come. Okay.
Oh, wow.
Okay, we have a...
So why is one stronger than the other? I voted you
You will give me the answer because, think in the spectrum more longer wavelength. This theme in the middle. You do it again, please. Let us look at something.
You guys
here.
know what stays the same when something's undergoing a transition? A phase transition like that?
It's like heaven. The math.
It's staying at the temperature that ice melts at. It doesn't change. So this is filled with liquid nitrogen, which wants to be at 321.
I thought today was super cool. It was really great to see. It was really nice to have physics kind of still in the classroom, but more hands-on and more working with different things that we deal with every day that we don't realize are physics, like refractions and things like that. And it was a really cool opportunity. I'm really glad we were able to be here today. Go Duke! Go Duke!
I love doing this. I love physics. It's better than doing it at school because it's more hands-on and you get to play with different instruments and see how physics is outside the classroom.
I really enjoyed today's event. Like, I felt like I got more out of this event than I've gotten out of like in class because we got to do hands-on stuff. So it was really cool. Overall, it was a really fun experience. I couldn't get any more pizza because my stomach is too small.
I thought it was good. I unfortunately didn't learn as much as others because I have already researched this kind of stuff on my own. So it's interesting though actually doing experiments because it helps you learn what you're doing and explain why that happens.
We should go wear our I'm sorry. Oh my gosh, you guys, we should go wear our t-shirts tomorrow and like advocate for science. Go science!
I said it was a see-through cup. It would look like the straws are broken. And that's refraction.
And we learned about how different mirrors, use light different ways. Yes.
This isn't going to be on the internet, is it? Oh, yeah.
Hey,